for the actual session to start. I appreciate you guys waiting just a little bit more here. It's cool to see all the international diversity in the attendees today. For those of us who are not morning people and based in the US, thanks for joining in the morning. I think that makes it more possible for others on different time zones. And for those of you on different time zones for whom it's very late at night, thanks for joining. A few things to say before I get started. First is, this is more of a lecture and less than a course. I think there's two reasons for that. The first is because I really want to lay the background and the context for Python as a tool for geo-professionals. And I think the best way to get through that concept is through lecture. So it's less interactive. In fact, it won't really be interactive until the end when it's time for questions. Feel free to use the chat while I'm talking to ask questions. And periodically I'll glance up at that and do my best to answer those questions at the end of the section that they were asked about. And the second reason why I'm doing this more as a lecture and less as a course is because then in the course, there's more room for the more fun, interactive kind of stuff. So there'll be a lot of talking. I'll probably go until about 9:45, so for the first 45 minutes or so. And then I can go ahead and stay on after. I know I scheduled an hour, I think, for this. But for anyone who wants to stick around afterward and chat, that's totally fine. And there'll be quite a few of us on here. I know the protocol typically is to mute yourselves and turn off your videos. And I encourage you to go ahead and follow that protocol during the actual presentation part. But at the end, when it's time for questions, you can type them, or you can just go ahead and unmute and turn on your camera and ask your question directly, and we can have a conversation at that point. But hold off on that until after the first 45 minutes. One question already, and that's a good first question. I recommend Anaconda for beginners. Spider is really popular, but Anaconda allows you to do that sort of line-by-line checking, and I'll demonstrate what that looks like just a little bit as part of the lecture today. Yeah, that's another good question from Poe. Let's see, what I plan on doing is sharing the slides rather than the video, but I'll think about that. That's a good question. You can access the video. I think I have your email addresses from Eventbrite from your signing up, so I can share the slides at least there, and I'll post them on the website as well. All right, I'm going to go ahead and get started because it's 9:03. Thanks again, everybody, for joining, and I appreciate your staying muted at the beginning here for the first 45 minutes or so when I get through this talk. So I want to cover 6 major points today. The first is the market for geo-professionals as it exists today. And second, in that context, how some folks are standing out professionally. Next, why Python is a big deal. Then what's happening in Python for geo-professionals in particular. So again, context and then zooming in on our use cases. And then what to expect from our course and how to follow through afterwards. And that'll give you a sense of, if you really want to take this course, what you can expect it'll do for you and what you can handle after that, what's in store for you after that. So first, the market for geo-professionals. So USA Today published something interesting back about a year ago, a bit more than a year ago in 2019, about the most employable degrees. And they were looking at undergrads in particular, but geosciences emerged as number 3. So the 3rd most employable degree of all the different options for what you can study in school. And that's because the unemployment rate at the time was only 0.96. So about 1 in every 100 people who graduated with the geosciences degree was not working. And decent average salary in the US, noticed that a lot of people who had geoscience degrees also went on to get a master's degree at least. So that might influence this somewhat. maybe fewer people are just trying to get jobs straight out of a bachelor's degree. But quite a few people in the labor force, so impressive that unemployment was so low for that degree. And this is 2009, right? I'll start talking about what happened this year in the next slide. So, and then number one was atmospheric sciences and meteorology. So kind of an earth science related degree there too. And unemployment was only 0.6%. So out of every 200 people or so, one person wasn't employed. Similar kind of salary. And again, a lot of people were getting master's degrees or above. And the reason why I included this on this slide here, this part about BA holders, so that's bachelor's degree holders with master's degrees, is because people in the geo-professionals world tend to be pretty invested educationally in doing geo-professional kinds of work. So if you're a petrophysicist and you have a master's degree and then you switch into a different profession completely, that's a big switch, given the momentum that you've already had educating yourself in that profession. All right, so moving on, what happened in 2020? So I think we're all pretty much aware that it's been a tough year for a lot of different professions, but just to kind of get some numbers behind that for the sake of context here. So about, notice this is a slightly different percentage than what we saw in the last slide. This is from the American Geosciences Institute. So geosciences doesn't cover all of geo-professionals, but just for the sake of coming up with some kind of numbers we can look at here, I found this. And what we see here is a comparison between graduates with geoscience degrees from 2014 to 2018 versus 2019 to 2020 graduates. And if we look at the percentage that are unemployed here from 2019 to 2020 graduates, it's way higher. It's like 40-something%, maybe about 9 times as much as their predecessors. So suddenly huge spike in unemployment. So it's become a lot more competitive to be a professional geoscientist. And I think this is a pretty solid proxy for what the world is like for geo-professionals generally, not just geoscientists. So it's much harder to get employed. And same organization, American Geosciences Institute here, and this is pretty recent information. We're showing how people who are unemployed, we're dealing with that. And notice that the total percentages of each of these three add to more than 100. That's because some people are both seeking employment in geosciences as well as looking for employment outside of geosciences. And it's kind of telling, if you've invested a lot and gotten a master's degree and been working as a geoscientist, and now you're looking for jobs in other fields, that means it's pretty competitive to find a job in the field that you've trained for, the geoscience or geo-professionals generally. And then there are some people who are not seeking employment at all, and there's various reasons for why that might be true. So a little bit bleak there, and just zooming in on one specific part of the industry, and this is perhaps where I have the most experience from my other firm that does unstructured data management for oil and gas companies. If we look at total US job losses in the energy industry, this is from BW Research Group, and they publish their stuff online, which is pretty cool. So this one, I'll share this slide afterward, but you guys can click through that and see. And there are a few other reports too. So 1.3 million people by April of this year had lost their jobs in the US alone in the energy industry, which is about 16%, 15 or 16% of total workers. And that eliminates all the growth that we'd achieved in the energy industry over the last 5 years. So just providing some numbers for the context there. And then here's some anecdotal information that might be interesting. So one friend of mine from a leading industrial service company says the bankruptcies, the layoffs, the furloughs have been pretty scary, and they keep coming next month in July. So this is a June quote. We've been told to expect another 40 to 60% reduction across the board. 60% reduction is a big drop in staff. And this is going to happen in July, or happened, or maybe it didn't, in July. So that's just kind of telling there. The only way to save the geo folks has been to plug some of them into evaluating potential acquisitions. Interesting quote here. This is from a team lead in an oil super major. So one of the big international oil companies, the big four there. And the point about geo folks, what he's saying is that people who are geo professionals Largely, they were working on exploration geology, looking for new and unproven reserves or semi-proven reserves or that sort of thing, and exploring how, whether and how to go and acquire and develop those resources. Are now having to sort of pivot and apply their skill set to helping the teams that are buying up competitors and distressed assets. So they found a use for those folks, but they had to, switch them away from what they had been working on, which is probably a tough switch for some of them. And I know this sounds crazy at two levels, but we have laid off every single geoscientist except for one person. And I'm glad I'm not that person. So I happen to know that in this mid-sized independent oil and gas operator, there were something like 30 people on their team as geoscientists. So going from 30 down to one, it seems as though there's a disproportionate cut in geo-professionals from the oil industry as compared to other professions in that industry. So as we move from a time of feeling of abundance and trying to grow and see what else we can do to a feeling of scarcity and trying to optimize what we already have, the folks who are more prone to work on exploration work are finding less to do. Okay, so that's all kind of bleak, and I'm sorry to start off that way, but here's something that's pretty encouraging, and this comes from the Bureau of Labor Statistics. So US information again here. And it's saying that, and by the way, this was published, or at least most recently updated this month. So this, I suppose, is still true based on whatever the Bureau of Labor Statistics is doing for their research. But if we compare the number of geoscientists who are employed in 2019 to what's projected for 10 years later in 2029, there's an overall increase by 5%. So geoscientists, except hydrologists and geographers, will be 5% more employed than there were in 2019. And then this is me paraphrasing what's on their website. And I'll share this with you guys so you can poke through it yourselves if you like. But learn to diversify the application of your skills. Don't expect as much from mining and oil, but you'll be needed to find and evaluate sites related to other energy, construction, environmental protection, and technical service. So there's a lot else going on that can use geo-professionals outside perhaps of where you came from originally. And so it's good to look for that and to diversify the application of the skills you already have. And then this is a real quote from this website. Their example is, geothermal energy plants must be located near sufficient hot groundwater. And one task for geoscientists would be evaluating if the site is suitable. So it makes sense, right? Maybe you're used to working on evaluating a different type of site or doing different types of geo-professional work, but you might be able to pivot into something like this. So that's how they're coming up with this more rosy figure that there'll be a gradual growth from where we are, even where we were in 2019 when things were good. All right, so that's kind of the backdrop here, the market for geo-professionals. Now, this next part is less based on research that I've done externally and more based on my own experiences. So I should probably step back just for a second and explain a little bit about those experiences. So I'm a chemical engineer by undergraduate training, and I worked for Shell, the big oil company, for about 4 years before getting my MBA. And then I've done a lot of management and digital transformation consulting work for big companies, mostly multinationals, a lot of them in the energy industry, but some in other industries. And so that has given me strong opinions about this, but it's not like I'm the world's foremost authority in how geoscientists should stand out professionally. So feel free to disagree and react to what I say here. But I do have a strong opinion and I want to share it with you. So who the current winners are, I think that there's 3 attributes that I've seen that really help people to stand out in the professional space, whether it's keeping your job, getting promoted, or getting hired to begin with. The first is if you're really efficient. So imagine if the average person on the job does 1x the amount of work in a given period of time. If you can do 1 point something, 1 point X on top of that 1x, then you're that much more efficient and you're that much less likely to be let go if there's some kind of furlough or layoff or something like that. So being efficient is great. Being data-driven is also really important. And I think of this as really, the ability to use modern data science methods like machine learning and that sort of thing. So are you actually driving decisions using data as opposed to going with your gut completely, or, kind of guessing and hoping for the best, which unfortunately does happen quite a bit. And I'm not just talking about the decisions you make as an individual worker. I'm also talking about the decisions that you help to inform from others, like, senior management or something like that. And third is versatility. So are you constantly looking around for what else you could be doing, which is, kind of hard. You finish your work every day. How do you make a habit out of then keeping your brain turned on and looking for what else you could be doing? So what this means practically is, for efficiency, the first big one is automating repetitive tasks. If you can automate something that you otherwise have to do manually, opening lots of files and cutting and pasting things and moving them around on your own, if you can write scripts to automate stuff like that, that's a really big deal. That really boosts efficiency. Perhaps through automation, but through other kinds of work, you can reduce the amount of human error by adding in safeguards or making sure that, something that doesn't actually only grab part of what it should have grabbed, when it's doing the highlight and pasting and moving around the data or doing the data manipulation. If it's a machine, it won't have human error. It'll have a different type of error, which is perhaps easier to flag and eliminate. And then if you get good at scripting to create tools that do things like this for you, then you can combine and eliminate workflows. So a workflow that's been automated has essentially been eliminated. But you can start looking at, what are other teams doing, and how does what you're doing, fit in with them, and can you, write something that will help to combine those workflows. And geez, from my experience, what I've seen, and to some extent what I've experienced myself, if you write software that does something, that automates something or speeds something up for your team or for your company, because you wrote it, you own it. And if others start using it, then you become pretty indispensable because you're the creator and the owner of something that has now defined the new standard of efficiency in your team or in your company. So that's a pretty important block there, that efficiency block. So data-driven, if you want to use modern data science methods, you have to have the right data. So, it's important to help ensure that the right data is captured. Think about, what do we wish we knew whenever we have to make a tough decision? What kind of tough decisions are we having to make pretty regularly? Or when we do have to make them, they're a really big deal. How can we set about, capturing that correct kind of data? And then just because you capture it, there's sensors on things or people are taking notes in the right places. Just because you capture the data doesn't mean that it's easily accessible. So you want to help be the kind of person who's figuring out where things get stored in a way that make them very easily accessible. And then finally, you want to be able to use modern data science methods. So I'm talking about machine learning techniques, something more perhaps than Excel's built-in linear regression on two-dimensional data. And then finally, versatile. I think of this as like, if you have the habit of asking, like, what else is going on, not just inside your team, and perhaps not just inside of your greater company. We saw that example of the oil major pivoting people from exploration geology into the due diligence on making acquisitions. But also, how can you look at what else is going on outside of your company or even outside of your industry that might make use of your skill set? So getting plugged into a bigger community and checking out what's going on there. How can you learn about it? And then how can you contribute to it? How can you add value to that kind of community? So don't be closed off and focus just on your work scope. Treat this sort of networking and learning as a continuous part of your profession. So I'll pause there for a second because I think I saw a couple questions here. Can I allow you guys to record the video? Deepak, I am recording this. I have to think about whether I want to share it or not. I'm definitely going to share the slides. So don't worry if I'm going fast. Enough people are asking me to share the video. What the heck? I'll just go ahead and share the video. That sounds fine. And Edward Kazier said, and yet the daily global crude oil consumption is only down 8 million per day. Who would produce the oil that the world demands? Yeah, definitely the oil and gas industry is going to have to come back, because I don't think other sources, and I could be wrong here, but I don't think other sources of of energy production are as prolific, easily transportable, that sort of thing. So I might be biased because I've spent so much time in the oil and gas industry, but I certainly think that it's necessary and will be for a long time here. So I agree with you. John Ajaya, why do I say mining doesn't look good in the near future? I don't know, John. I'm just showing what the research that I did said. My guess is because mining tends to be the foundational industry that manufacturing is built on, and if there's less consumption of goods, then manufacturing is down, which means that the need for the raw materials is down, and that might be what happened this year. And there's nowhere to go but up, it kind of seems, but who knows? How about geophysics? I'll get into that, I think, in a little bit, Moto G3. So I'm going to keep going here. How to stand out professionally. Let's move on to why Python is a big deal. So this is from Python's official documentation on its own website, from updated this year. Python is a high-level general-purpose programming language that can be applied to many different classes of problems. So when I say high-level general purpose, what I mean by that is there's actually this spectrum that programming languages fall on. And on the one end, we have low level. On the other end, we have high level. So people who are doing software development will ask about this and talk about this. Oh, this language is more high level, or this language is more low level. And what they mean by that, high level, essentially, the concept is that you're just giving the machine, when you're doing any coding, the high level overview of what you want it to do for you. And you leave the how it's done, up to the machine. So if I say create a variable, then that's kind of a high level thing to say. If I say instead, and store it in this specific place and give it this specific type and use this operating system to do it or something, or put it onto this part of this hard drive, that's more low level specification that high level lets you just kind of skip over. So the code itself has little dependency on outside structures or services. Whereas low level, you kind of need to tell the machine how to handle each instruction, like which operating system or processor to use, or where things get stored, using memory pointers and that sort of thing. So the code does have major dependency on outside structures and services. So what this means practically is high-level software languages, if you're developing in a high-level language, it's easier to learn, typically. Low-level, a lot of languages are really hard to learn. It's easier for humans to find and troubleshoot problems inside of their code, because you only have to make sure that the logic is consistent for the human. You don't have to make sure that the hardware is functioning properly to execute the code for you. It's more likely, used to do something on, a human interaction level, like render a web page or interpret user inputs or something like that. And the associated files tend to be more versatile. You can use them outside of the original context that you created them for. So once you've scripted something, you can apply it to a different kind of workflow, potentially, and not have to make too many changes to it. Low level is kind of just the opposite. It's quicker for machines to execute, but much harder for humans to learn. There's less what we call overhead when you're interpreting human-generated code. So overhead means if I tell the machine to do something in a high-level language, it might have to evaluate a lot of options for how to actually execute that before deciding on one to pursue, which uses up storage and processing power. Versus low level, it's all been written by the human. The machine just does exactly what you tell it. More likely to do something on a machine level, like sound a buzzer or vary an engine speed, and the associated files are smaller. So why am I going through all this detail when I'm talking about Python as a high-level language? Well, Python checks these boxes as a high-level language. So great, that's good news. Easier for people to learn, easier for us to troubleshoot problems in the code that we've created. But what's really special about Python is that it's still really fast for machines to execute. I have kind of a crappy laptop here, and I can do some pretty in my sense, compared to what I was used to before, some impressive data science on, pretty large data sets in timeframes that really make sense in my normal work. So that's great. And I don't know how Python does this next part, but this overhead thing, and this is related to the first point here, but this overhead thing, the execution is like downright magical. Somehow it figures out the best way. If there's multiple processors on your computer, use this one for this and this other one for that. It kind of does that stuff for you behind the scenes and seems to do a pretty optimal job because it's so fast to execute. It's more likely to do something on a machine level. Well, hey, Python can interact with machines very well, and there's a lot of documentation for that. That might not be as important to us here, but in the geo-professional domain, but it just helps to prove that it's a good language to learn. And a lot of the Python files can be tiny. Maybe your data sets are large, but the Python files that you've written to analyze and manipulate and graph, visualize, evaluate, those files can be really small. So another interesting thing about Python, this is the website pypi.org, the main hub for the open source community of Python developers. And I've enlarged this part here just to kind of show these numbers, but there have been 2-point-something million releases of libraries and packages made by people just to solve problems that they want to solve using this language. And that's because of its power and versatility that I talked about in the last slide. So tons of people working on all kinds of niche domains, creating packages and libraries to help others in those niche domains get stuff done. So, whatever you're into that's like some very niche thing that might need programming, there's probably some library out there, perhaps multiple libraries, that can help you get stuff done using Python in that domain. So to 150,000 projects, so about 8 releases per project. So pretty impressive in terms of how prolific these open source communities are. So if you ask Python how many people are using Python, they say they don't really know, and that's because they're not tracking because it's free to download. So, and there's lots of places where they let others download it from. So because it's open source and free, they're not really keeping track of that themselves, and they're allowing others to upload Python to their websites and then let people download from there. So it's proliferating, but you can't get the right number from Python directly. So we look at other proxies for how Python is becoming popular. One of them is through Stack Overflow, and this is dated. This is back from 2017 here. But it's an interesting graph, and I hope Stack Overflow updates this and publishes a new one because I think the numbers will go up even more. But what Stack Overflow is, it's a website where people go to ask questions about code. So, hey, I'm trying to code something and I'm having this kind of problem. Can anyone help me debug or figure out what I'm doing wrong? I'm really stumped. Or maybe I don't even know how to do this at all. Can somebody suggest a way for me to start learning X or Y? So Stack Overflow is a good website that way. And the answers you get are also from the same community of users, and they're motivated to answer because it makes them look good. They get, voted upward, and they can add to their resumes and their credentials otherwise that, hey, people like my answers in Stack Overflow. I'm becoming recognized as a kind of a guru in this area, whatever. So the number of questions that people are asking about Python has really increased recently from, looks like, end of 2011 there, or 2012, all the way up to 2017. And this is in percentage of overall question views each month. Another interesting one here, traffic by industry to Python. So this is all about Python here, no other, here we were looking at C++ and C# and Java. This one, we're looking only at Python. And what we see is the percent of 2017 traffic going to Python, so questions asked about Python in Stack Overflow versus 2016. So if an industry dot was below this dotted line, that would mean that there were fewer questions asked in 2017 than in 2016. So we see general growth. We're above this line in every case here, and by a pretty significant margin, because this is percentage growth year over year. And then the size is the overall percentage of traffic. So energy is that tiny little dot right there where my cursor is. finance, tech, which just means software, manufacturing, government. So a lot of people from a lot of different industries are starting to use this. The other way to, as a proxy, figure out how popular Python is just to ask people in big surveys. And one of the things that Python is really good at is data science. So because it's very quick and because it's very easy to script, a lot of data science methods run into a challenge of, if you're not careful, being sort of like a black box. And to make sure you really understand what's happening behind the scenes, it's great to use a program like Python. It can be dangerous because Python will let you do things with very little script and turn things into a black box if you want. But it also lets you like really take a look at what's happening under the hood. So it's become a very popular tool for data science. And for that reason, people have started to keep track of Python's popularity as a data science tool. One of those organizations was DZone, and in 2017, they released this information showing a bunch of different tools that people like to use for data science. So here's how popular those tools were in 2015, and then in 2016, and you see Python just underneath R, a different language that R is kind of a software package as opposed to a programming language to some extent. And huge growth year over year for Python. In addition, things like scikit-learn and Spark are actually tools that people can use in Python. So maybe these could be combined and further accentuate Python's growth there. And then KD Nuggets did a similar study across the whole world, tons of industries, lots and lots of correspondence here for the survey, just like DZone did in 2017, they did in 2019, showing the next 3 years. So we had 2015, 2016, and then 2017 up through last year. And we see Python has really emerged as the winner in terms of popularity for data science tools. Lots of reasons for that, but I've talked enough about this part, so I'm going to move on from why Python's a big deal to finally getting into geo-professionals here. What's happening in Python for geo-professionals? Right, so Moto had asked about this, so hopefully this next section will answer your question there. So coming back to my own opinion about what makes somebody really stand out as a professional in the geosciences space, let's look at how Python enables winners in this area. So for the first point, if you're trying to automate repetitive tasks, in Python, you can learn and execute very quickly. So you can learn how to do stuff in Python as compared to a lot of programming languages very quickly. It's a great language to start with. And because it's so versatile and it's been growing so quickly across lots of different industries, you might not really need to expand out from Python into other software languages to the same extent you would if you'd started with something else. The other thing to say about automation of repetitive tasks with Python is as you start to script something in Python, it's very versatile. You can take what you scripted for one task and use that logic to help you with the next task. If you compare that to, say, some kind of industry-specific tool that was built to do a specific workflow, you can't say the same thing about that tool. You can't take a tool that was designed by software developers and you're a consumer of, and use that tool to do something it wasn't designed for. It just lacks that versatility. And what percent? Ask yourself what percent of the problems you work on at work that involve manipulating data or opening, closing files and visualizing data and that sort of thing. What percent of those tasks are kind of unique to yourself and unique to your own workflow as part of your team? Even as a whole team, a lot of what you do depends on what kind of work your specific team is working on and isn't really captured in like a one-size-fits-all, off-the-shelf software product. So being able to script your own tools, using the scripting language as a tool to then create tools to handle your processes for you is really valuable. That means quite a lot. And the barrier to entry on that has come way down for Python. So the next part about reducing human error here, it's very easy to debug and test Python script. And a lot of that has to do with new environments that people have created for Python that let you, look at what's happening line by line and test things as you go. You don't have to just compile the entire piece of software you wrote and then say, let me try running this. Uh-oh, there's a bug somewhere. Now I have to figure out where it is without any extra help. Instead, you can look line by line and see what's happening and make sure it makes sense. And that's invaluable. That makes such a huge difference. It's really easy to safely share what you've created. Not just inside your company, but outside your company. You don't have to worry about just because it's developed open source doesn't mean it's like less stable or that people are gonna necessarily have some way of, building a back door into what you're doing and looking at what you're doing or something. Especially, you can build tools that manipulate data that don't store the data in the tool. So, if someone got a hold somehow of your file, I don't know how they would do that. They'd have to get into your computer the same way, to take a Microsoft product file or something, then it wouldn't have the data in it necessarily. So you can store your data on a server, something, secured by a big name like Microsoft or Amazon or something. On the data-driven side, you can import lots of file types and visualize and clean them very easily. So that's great, and I'll show you an example of that soon. There's so many different kinds of files, and it can be a hassle if you want to compare data across different file types when most programs can only open one or a small subset of file types from the amount that you're actually using in your workflows typically. And it's really easy to visualize and then clean the data right there inside of Python. And you can safely store it elsewhere so that you're not tampering with the original data. And when it comes to use of modern data science tools or methods, I alluded to this earlier. I put dangerously in quotes here, not just because, when people say, hey, I know enough to be dangerous, you can get to that level quickly. So it's easy to become, dangerously useful in data science methods beyond just linear regression pretty quickly in Python. The thing to watch out for, though, is that it's so easy to do that sometimes you can start, getting answers from models and you don't understand what's happening in those models. You can train a model in, 2 lines in code without having to create the model yourself in the code. Does that mean that you're using a black box, and should you be using it? So there's some questions to think about in that part. But if you want to get good at data science, Python's a great way to actually do it. And then the versatility part, because Python is use case agnostic, it's really easy to take something that you've written and then apply it to some other kind of context. You can remove the proprietary info, which is typically the data, and then take the process, which might be, similar to somebody else's process that's shared openly already anyway. And because you understand it, you can then apply it somewhere else. And there's such a huge open source community working on this stuff that it's not that hard to find a way to plug in and start learning what else you can do or how else you can add value. And if you think about it, this is not from Geo-Professionals, but the American Institute for Chemical Engineers last year in their annual conference, the keynote speaker was talking about how if you have Python on your resume as a chemical engineer, you're something like 4 times more likely to be hired. And your starting salary, based on information that they had scrubbed from Glassdoor, where people report their salaries, was something like $20,000 per year higher as a starting salary if you know Python than the same person who doesn't know Python on average. So pretty impressive boost of salary. Now, why is that? It's because if you know a tool like Python and its applications are very versatile, that means that you could potentially go work somewhere else, not even just a competitor to your current company, but a completely different industry, and still be able to add value. So, that raises the price, because if somebody else can pay you more in a different industry, well, now they're a competitor essentially. You're not stuck with firm-specific skills. You have generally applicable skills that are in demand. So you deserve to get paid more. Oh, and by the way, Python is free. That's an important thing to consider in this mix. So I'll show you a quick example, and then I'll end by talking about what to expect from our course here. And I'll take some questions after this example. So let me pull this down. And then, So if I open this folder here, notice I've got inside this folder, here's some Python files, here's an Excel macro-enabled worksheet, and notice Excel gives me its little icon for this because it knows that I can double click and open this in Excel. Here's a normal Excel worksheet. I can open that in Excel for sure. Here's a comma separated value file, so a .csv file. Microsoft Excel could open that easily as well. But what about these LAS files? So geo-professionals, geoscientists are used to dealing with LAS files. What happens if I just try to open this, in Windows? Typically what happens is if I were to just double click on it, something like this would pop up. And it would say, hey, I don't know how to open this. Maybe you can find an app that can open it for you. So I went ahead and actually found one such app. And I'm not trying to pick on LogScope. It looks like it could be pretty cool software here, but I want to use it to make a point, which is, even though it's free to open, it's free to download and get started, whenever I open it, it tries to get me to purchase some sort of upgrade. And if I click on purchase later, I'm not really seeing very much information. I tried to open this thing called fake data, which does have a lot of data in it. I just created this LAS file as an example, but I'm not really seeing anything useful here yet. So maybe I want to take a look at the header, and then it says, sorry, I have to basically pay money just to look at what information is in the header here. So, nothing against LogScope, but there are a lot of barriers that prevent us from just tinkering around with data stored in these niche file types. LAS file types are very, very useful, but because they're only common to a certain type of worker, there's a lot of paywalls in the software typically that we would use to, to open them and evaluate them and that sort of thing. Versus if I hop into to Python here, I can just import some libraries that I've already installed that will let me do that. And don't worry if you haven't done scripting like this before. This is the kind of thing that if we were in a course, we would go through, together and make sure all the steps were clear and intuitive. But I'm importing some libraries here, and then I can just say, hey, I want to take something from Lasio, this read method, and I want to read that same file, fake data.las. And remember, this is free, right? So I didn't have to pay in order to import this, and Python accepted that. So I now have this LAS object here, which is the information that I read from that LAS file. And so I can now ask for information like, the header. This isn't organized in the most pretty way ever because I asked for everything in the whole header, but there it is, like it's all there, and I could ask for it in ways that are a little bit cleaner or more specific. Like for example, if I wanted to know the version of this LAS file, version, I can see it's a version 2. Hey, and that lets me know what else I can expect from this kind of LAS file. So I didn't need to pay for that. I could ask for the data that's contained in there. And I don't want to get too much into the weeds here. We might not all be using LAS files, but just to give you a sense that there's a lot of things you can do in Python. Then I could start to grab this data and manipulate it programmatically, or combine it with other data from other LAS files, or visualize it, or that sort of thing. So pretty useful stuff there. All right, I'm going to take a look for questions here. Nothing else since before, and we're almost out of time, so I'll keep going here. So that's what's happening in Python for Geo. Now, what to expect from our course. I'll talk about that kind of quickly, and then I'll go into the follow-through, what would happen if you were to take our course afterwards. So there's 4 parts to the course. The first part is we got to get you up and running with a scripting environment. So that environment that I just showed you, how do you download something like that? How do you set it up? How would you treat it just like, say, Excel, and be able to open files and save files somewhere and that sort of thing? And then, just general operation, what are the different menu options and that sort of thing? This goes really fast. And in fact, I'll share a webinar with you guys in which I go through this in detail. I'll share that link with you. So This goes really fast, and it's actually very easy. And that's another great thing about Python is that people have created things like this. It used to be kind of hard to get set up and, using your terminal and everything on your computer, or your command prompts, depending on what operating system you're using, to even just get started. And that was very daunting and confusing for beginners. And because there are a lot of dependencies on what kind of operating system or software you have on your computer already, it's hard to find tutorials that are one size fits all. That's not necessarily the case for Python. So I'll share that with you later. Part two, this is where we spend a lot of time, which is building that basic proficiency in coding. So you have to learn about different types of data and about different scripting commands that are general scripting commands before you can start building functions. And then you can import libraries and start using methods from those libraries. And some libraries are so common that it's important to like get a handle on those methods generally. So once you have this foundation, then you can stand on it and start doing stuff on your own without the need of a teacher, because there's so many libraries out there that have good documentation that come with them for free. So this is a really valuable part right here. The next part is we'll start talking about how you would use this proficiency to accomplish basic workflows that are kind of general workflows, not necessarily just geo-professional workflows. Like, how do you import different types of files? And once you get your data in there, how do you clean it and analyze it and visualize it and do some sort of analysis and that sort of thing. And then finally, we'll talk about the geo-professional workflows. And I'm pretty open on this. I had in mind to go through LAS data, well logs, show how to make heat maps, and a few other geo workflows here. But if there's something in particular that you do that you would like to learn how to do in Python, if you're interested in this course, send me an email about that. And I'll give you my contact info in just a minute here. And we can go over that, we can add that to the course. So about our Inly's teaching philosophy, we're stuck with remote right now. And, so the course will be conducted through Zoom for safety reasons. So that's less, a deliberate decision on our part and more out of necessity. There's some net gain and convenience, like, hey, you can be logging in from anywhere in the world, and that's nice. You don't have to put on shoes and leave your home. But there's this challenge, that this adds to how do we keep it engaging? Typically, if you go to a course and it's in person, you have a little bit of nervous energy and, you're on the spot, you have a sense that it's live, and that contributes to how real it feels to you. So we overcome that with the rest of these features here. So it's synchronous. A lot of courses that you might find are pre-recorded videos, and I feel like those don't work as well. I've tried those myself, and I hear from a lot of people that it's much easier to learn if everyone's live together in the same virtual room. You can react to content and ask questions and that sort of thing. It's really interactive. So you're not just listening to me the way that you are right now. Instead, you can, play games where we help to drive home the points for how things work. And so that way it's engaging and fun, but it's also driving home the points. And so you're going to remember things. You can fill out surveys. How many of you think that this is the right way to do things? Well, it turns out in Python, this is weird, but it works this way. Then you remember that better, and little challenges. We'll split you into breakout rooms so you can work on projects together as a regular part of the course. We try to make everything intuitive. That's a big deal for us. So we want to teach in such a way that the content is memorable and the learning process is interesting. And then practical. So the expectation is that you can put this to use on the job right after the course. So it's not just that you remember what you learned and you have this intuition that helps guide what you should expect when you're trying to implement this in the real world. But the course content is not just theoretical. Like, the goal is that you can just apply it directly. And if you're in transition or if you're a student, this is the kind of thing you can add to your resume and then prove that you know to help you be employable. And then finally, it's cheap. So we want this to be accessible to folks who are in transition, as well as to firms that are looking to stretch their often thin training budgets. So you get a certificate when you take courses from us. So that's all for the marketing part. And then how to follow through afterwards. This is like something to think about if you're considering taking a course in general, not just our course. you get to keep the materials, like you should be, right? And you do from us. So once you have these materials, we've created them in such a way that they're not just exercises that you do during the course to learn the concepts. They become kind of a blueprint. Like it's something that you can then reference and borrow code from when you're trying to implement stuff on the job yourselves. But you can also go over it again at your own pace to help internalize this stuff. So I think that's an important thing to have in mind and expect to do if you want to like really get the most out of the course. We also have this content guarantee thing. So if you pay us to teach you something and the course finishes and it's not completely clear to you, that's okay. That's not like your fault. A lot of this stuff is complicated and we boiled the course down to be like a 12-hour course. So you can like schedule time with us. Even after the course is already done. If you want more help, you can just hop on a call and we'll talk it through with you. Or you can send messages to us to make sure that you fully understand stuff. And then finally, you can join communities to keep learning and applying these skills, which is important, that versatility part. You want to be able to keep learning. It's not like you take this course and then you're done. I think that generally what's happening in the world is that people are moving away from spending a lot of time on the job executing workflows that are predefined for them, and instead are spending less time on the execution part and more time on figuring out how is the optimal way to execute and what other things can we be doing. So learning on the job as part of being productive is becoming more standard and acceptable. So lean into that. You can explore with others from the course who take the course with you, as well as people who've taken other Inly courses. And then of course you can join these Python communities once you have that foundation to know what people are talking about, join in with other geo-professionals and contribute there. So some things to maybe check out. Yeah, here, actually, I'll just pull that up because people are asking about it. So here's the website. Let me go to the courses here. So we've got a discount, I guess, until the 23rd. So it's $300 to whoever asked that. And this one is 3 days during the week of the 29th, versus down here, there's another one in October, which has a different schedule. So if I look at more information here, so you can pick either of these two sessions. These are both in US Central Standard Time, but one of them is 6 to 9 p.m. on 3 days, and one of them is 8 to 12. Yeah, so you can read about what are the different sections and kind of the stuff I just talked about. And then there's a lot of like background information. If you want to watch a past event or read more about the context or that sort of stuff, there's a lot of information here. So I'll share this. I'll share this link with you guys. Another thing that maybe is worth checking out. There's this great energy and data. Let me get on Google. There's this great conference that's, I think, still taking place online. That is, there's a webinar in there about, yeah, here we go. Get into the webinars. I'll share this link with you guys too. Here it is. So this is that webinar I told you about where we went through and like talked about how to download and set up Python and then gave some more demos. I didn't get into that as much this time, but I'm going to share these links and my contact info with you guys here on the chat. And then I'll take some questions for people who want to stick around. So this is the webinar about getting started in Python. And then here's Inly's website. That's and then my contact info. You can ask us questions right there on the website. There's like a form you can fill out, and that's the equivalent of sending me an email. But if you'd rather just send me an email, you can send it to alec@inly.llc. All right, so I will pause there for questions. Feel free to ask them in the chat or to unmute and ask them. I'll share these links as well as the slide deck, as well as the recording of this video with everybody via email afterward. So no need to ask about that, but if anyone has any other questions or comments, maybe especially on the part where I tried to lay out the groundwork about like, what is the background for this stuff? It seemed like people had a lot of thoughts there. So feel free to share those with everybody. Aha. From the Python library, are there many oil and gas or specifically geology entries? Can you show us quickly the library for petroleum geology? Yeah, there are. I can't show you, I'm not going to show you that right now. But yes, there are a ton. There perhaps aren't as many as there are in some other professions. If you remember that slide we showed earlier about who's using Python, I got to go way back here. It's something like, yeah, so there are perhaps fewer people in the energy industry using Python than in some other industries. And for that reason, there perhaps are fewer libraries that are energy related than related to other industries. But that doesn't mean that it's a bad idea. So here's the slide I meant. See this energy, how, people who are asking about Python who are energy industry professionals make up a very small percentage overall. And I think that's because the energy industry tends to be like kind of slow to adopt newer tools. But that's both a disadvantage as well as an opportunity, because the people who do adopt them tend to stand out all the more. And if it truly is a better tool, which the general worldwide data seems to suggest, then you have that added capacity as a bigger selling point because there are fewer others who also have it. Is Python useful to develop query modeling from a chemical composition standpoint? Hey, Ricardo, I would say if you could email me that question and maybe provide a little bit more detail about it, then I could probably answer that better. I could go find something for you to show how that happens. I'd be surprised if nobody has ever done that before in Python. I'd be really surprised. There must be some kind of library out there. And typically when people create libraries, because everything's for free on Python, it's open source. The goal of creating it is the prestige of then having others use it and being able to say, hey, I'm the one who created this, which tends to mean that there's good documentation. Once you have the basics of Python down and you know how to interpret that documentation, there's good documentation out there. So I haven't done that myself, query modeling from chemical composition standpoint, but I want to take a look at that. So send me an email and I'll try to get back to you. Have I used Python web frameworks to develop GIS web apps, for example, Flask and Django? I haven't, but people in my firm have. Flask and Django are like extremely popular. And if you just look at, I think actually, if you go to this Stack Overflow report here and browse around through it, you might have to click on some links there. Another breakdown that they do is what about Python are people asking? Are they asking about web design, or are they asking about data science, or what? And Flask and Django show up quite a bit. So if that's a proxy for popularity, then a lot of people are using that. Are Python users less likely to get fired, more likely to have higher wages? Yeah, definitely. Both of those things are very true. So I talked a little bit about this, but I want to make that point again and make it a little bit clearer. So about less likely to get fired. Typically what happens is if you build a tool that you and others on your team are then using, others in the company are using, and that tool is very helpful because you built it, you're the one who kind of winds up managing it. And that doesn't necessarily mean that it takes up a lot of time to manage. You might have to train people about how to use it if they're not quite sure how to execute the code or something. But typically you can build like a little guided user interface that comes with it, and it says, upload your data here. And maybe it throws an error every now and then. You have to go look over their shoulder, but that just reinforces your utility. You're the one who understands this stuff, and people are relying on you, and that kind of makes you indispensable, right? Like if those tools are helpful and you're the one who gets them and understands them. Yeah, from what I've seen, especially in traditional industries, that's less common. Like people don't typically spend the time to do that, and so the ones who do really stand out, and then more likely to have higher wages. The point there was, if you really know how to script in Python, even if you've applied that scripting to your profession, to your company, to your team, because you know that foundation and you know how to script, that's a valuable skill set outside of just your industry. So your skills are transferable, which means that they have to be paid higher, because whatever the highest amount you're able to get from those skills, potentially you would go take that other job that pays you more. So that puts pressure on your company to pay you the same amount to keep you, because you're useful not just to your company, but potentially to other competitors in other industries. Main issue is the broadness of Python. How can I learn code in Python more efficiently? For example, we have lots of solutions in NumPy or Pandas, yeah, and it's not simple to stick to just one of them. Yeah, I think that's absolutely the issue, and that's the reason why Python hasn't just completely taken over the entire world there. There is like a barrier to entry. Because it's super powerful, it can't be as user-friendly. If a tool does just one thing, it's really, really easy to predict how the user is going to interact with it. But if the tool can do all kinds of things, well, then there's some ambiguity in how to put it together to do something in specific. And you need to learn how to navigate that ambiguity. So how can you learn to code in Python more efficiently? I think what you need is some person, organization, class to teach you. And once you get that basic foundation and you can stand on it, then you don't need anyone's help anymore. You can just look online and find libraries and figure out, okay, well, if I'm trying to solve this problem, these folks are using something in pandas, and I don't really want to do it in a data frame because that's not the best method. I'd rather use a NumPy array. Oh, here's a better, library where everything is NumPy native instead of pandas native. Like, understanding that isn't hard. You can do it in like 12 hours. It's not super tough. Thanks, Ricardo. Yeah, I'll look for that email. Thanks, Kelly. Yeah, I appreciate that. Anna asked a question. Something I missed from in-person training is a one-to-one short discussion and practice. I understand the current situation won't allow in person, but have you considered to add the course an additional one-to-one section? Yeah, we did that for the summer program, Diana, that just finished. It was a much longer course because it went through into quite a lot of nuance in Python as well as in Visual Basic for Excel, and explored like the intersection of those two things. And then it had a whole nother section on data science. What are these new machine learning methods that seem to be making such big waves in industries around the world, and how can you get to the point where you can use them competently without treating them like a black box? And in that course, we had one-on-one sessions with everybody. We still offer that, but we set it up separately from the course. So there's kind of two ways to get one-on-one sessions. One is if you send an email and say, hey, I'd rather just learn individually, then we can set that up for you. And then it's really up to you. So we don't have to necessarily go through the same course as it's written on the website. And the other is if you take one of our courses and you still have questions because something wasn't clear, about the content that we decided to cover in that course, you can schedule time with us. And those review sessions might not be one-to-one, but sometimes they are. So that's that content guarantee thing. If anyone ever takes a course from us, we guarantee that you will understand that content. So we'll do what it takes to help you understand that content. Do I have a quick example of Python application in geoscience to show now? I think I'll make that a separate webinar, Raphael. It's a cool idea to do it at the end, and there's still quite a few people on the call. But I didn't set out to do that, and I'd rather be deliberate and pick one that I think is a good one to show. But for now, all I really showed was that you can pull in LAS files. So I don't want to disappoint you, and I'll come up with something and show it. I think I'll do that on another webinar, though. Well, it looks like I've caught up with the questions. I'm happy to stick around as long as others are on this. I don't have anything for the next 25 minutes or so on my calendar. So thanks everybody for joining. I really appreciate it. I know this was kind of a straight up lecture, and remember that the courses don't need to be like that. And I tend to make them in such a way that they really aren't. So for any of you who've taken a course from Inly before, you'll know what I'm talking about. Mustafa says, main purpose is you're having a strong domain knowledge. Histologs is an example, but you still cannot grasp how to use raw data to visualize or apply ML techniques. Yeah, definitely, Mustafa, that's an issue. So, you know what you're doing in your field. A lot of people have master's degrees, years of experience, have worked with multiple companies, really dialed in their skills to do their domain execution well. But then there's a lot of challenges that come from finding data and cleaning it and organizing it and then interpreting it. And that interpreting part might have some room for improvement even inside of that domain. So it could be that some of these data science techniques that are becoming really popular right now are also useful inside of a domain that traditionally hasn't used them. Those are worth learning in addition to just generally how to use a tool like Python. All right, yeah, thank you. This is great. I really appreciate people joining. Time is precious, so I hope this was useful. I'm sticking around just in case others are processing and have other questions.
Oh, I'm going to talk because I got tired of typing.
Oh yeah, go for it.
Can you hear me, Alec?
I can hear you, yeah.
Good. Thank you. Thank you for the presentation. I think that something that I have learned lately is definitely, well, Python is very strong. I love that it works in Mac and Windows, in everywhere. That is not kind of like that limitation, right? But
Yeah.
something that also is I found very important is that there are softwares there that they have their own module for Python. So it's going to be very combined. For example, QGIS, that is an open source for GIS data, and it has their own module to create your own customized, workflows. So it's good because you already have a platform that is the QGIS that is very software normal, with tabs and very visual, but also have this capability of having the Python include there. So it becomes definitely more powerful, those softwares that are already there available.
Yeah, I think that's really smart of them, like strategically. If you see this Python wave coming, you're destined to be obsolete if you keep your thing closed off and you don't embrace the rapid development that's coming from this community, the open source community. So to combine what you're already good at with that community why would anyone try to reinvent the wheel if you've already handled that part? So, then you kind of secure a place for yourself in this new reckoning. I think that's a smart way to do it. Yeah.
Yeah, you see that also with commercial ones. This Schlumberger software, Techlog, and Petrel, they have also their models for Python. And so yes, it's very applicable for sure for this type of skills.
Yeah. Yeah, and there's also this trend, as long as we're talking about oil and gas and energy, there's a trend towards sharing more data. If I think about places like Canada or Colorado where um, there's been more mandated sharing, people tend to be better at using tools to scrape data and analyze it than in places like maybe Texas where traditionally people don't share, or organizations don't share data. So it's harder to find that data, and therefore people are less good at pulling it and finding it when they need to. So that general trend though is away from that example and more towards like sharing, open subsurface data universe, things like that. So when people have access to more data, then it kind of drives them to learn more about data science and look for tools that are good at that. And that kind of points towards Python as well. Yeah, good points. All right, thanks again. It's kind of getting quiet here, so I'm thinking that we're finished up here. Yeah, look out for an email from me. All right, thanks again. Bye-bye, everybody.